Hello everyone, I'm Agneet, and today I'll be talking about our work, Revision. Rendering tools enable spatial fidelity in visual language models, which will be presented at ECCV 2024. One of the major struggles of text-to-image models is the inability to generate images that faithfully respect the spatial prompt. As shown here, the models either fail to generate both the objects mentioned in the input prompt or are not able to generate images where the spatial relationship is maintained. In this work, we aim to solve this problem in an efficient, training-free manner. In Revision, we develop a training-free approach that provides additional conditioning to a T2I model in the form of 3D rendered images. Our motivation in developing Revision is to combine the strengths of graphic rendering tools like Blender, which enable deterministic and precise object placement, with the ease and intuitive workflows of T2I models where users can generate images simply by typing a sentence. The revision framework takes in an input prompt and generates a spatially accurate rendered image. The input prompt is parsed to extract the assets and the spatial relationship between them. The asset library includes a large human-inspected collection of 3D models of realistic objects with variations in texture and shape. The coordinate generator controls deterministic generation of 3D coordinates of the object and camera, given the object names and the extracted spatial relationship. The scene synthesizer assembles a 3D scene consisting of 6 main components: a camera, a light source, background, floor, and 2 objects. The position diversifier ensures diversity in object orientations, backgrounds, and camera angles for each invocation of revision. Shown here is an example of the position diversifier, where given the same assets and relationship, revision can generate different looking reference images. In revision, we reformulate the standard text-to-image setup into an image-to-image setup process conditioned on text, where the input image is generated via our rendering pipeline. We use STEdit within our Stable Diffusion pipeline and perform image generation guided by the reference image as shown here. We also explore the ControlNet backbone, which allows fine-grained control over Stable Diffusion. Using ControlNet allows us to address 2 key points. Our reference images provide enough spatial information even when low-level features are extracted from them, and we can mitigate any attribute-related biases present in the assets. We present our results on 2 benchmarks, Visor and T2I CompBench. As shown, our method significantly improves the ability of baseline methods to improve spatially consistent images. Across all spatial relationship types, Revision achieves a consistently high performance score across the Visor metrics as shown, a shortcoming prevalent in other methods. For example, the largest deviation in Visor performance for ControlNet plus Revision is 0.21% between left and below relationships. In comparison, Control GPT deviates as much as 6.8% for the same. Utilizing white backgrounds that exclusively feature the 2 objects in question minimizes potential distractions for the model. Conversely, when the model is presented with initial reference images incorporating indoor or outdoor backgrounds, it exhibits the capacity to identify and leverage distracted objects, resulting in the generation of diverse images. As shown, all generated images maintain spatial accuracy, but noisier reference images result in greater diversity. We also studied the impact of the number of denoising steps and its trade-off with photorealism. Through revision, models can preserve their spatial coherency while iteratively demonstrating a higher degree of photorealism through more number of denoising steps. Revision can also be extended to prompts that include 2 spatial phrases and 3 objects, and use these images to guide T2I generation as shown here. In this setup, we studied the generalization aspects of revision. We consider prompts containing exactly 1 object not found in the revision asset library, which we call an out-of-distribution object. Given a prompt that mentions an OOD object, we find the semantically closest object in a library and use their corresponding image as guidance. For example, we generate an image of a chopper above a bicycle by providing a reference image of an aeroplane above a bicycle. We also developed the RefQA benchmark to evaluate the spatial reasoning abilities of multimodal large language models. Leveraging the determinism of the revision pipeline, we construct a new visual question answering benchmark where each question consists of negation, conjunctions, and disjunctions. For each image, we create 16 question types to evaluate a combination of spatial and logical reasoning abilities. While most models reason well over simple spatial relationships, they have a large performance drop when presented with the opposite spatial relationships. For example, Lava 1.5, the best performing model, has a 58.17% decrease in performance when probed with simple versus opposite spatial relationships. All models also suffer under adversarial settings in comparison to their simpler counterparts. Comparing Lava's performance for and adversarial combined AND questions, we find an 85.88% drop in performance. Revision can also be extended for diverse applications in the future. Currently, we support 100 plus assets, but more assets can be added. Furthermore, final image generation is also impacted by the initial assets used. These can be alleviated by using stronger T2I models such as SDXL, SD3, or Flux. Furthermore, currently we focus on spatial relationships, but it can also be extended to other compositionalities like shape, size, and texture. Thank you for your time. Through this QR code, we link our paper, data, and code.